Video. Today we're going to show you how to just do a quick test debug of eBot, but we're going to do that using Scratch in tethered mode. There are three ways to do it. You can do it in eBot app, you can do it in tethered mode, or you could do it in compile mode, and there'll be a video for each one. So this one's covering just doing a quick test program of eBot using Scratch in tethered mode. Great, first thing you need to do is make sure you've got a fresh copy of eBot's firmware. So you will need to open up the eBot app and refresh the list there, find the COM port, upload the firmware. So this is our firmware, stem in the box firmware. You don't want to put the make block firmware on the eBot. You can, but you will have to use the make block blocks. You can't use our Scratch blocks. Great, so it's successful. So now what we need to do is connect. So we've connected, it's connecting. Fantastic. So down in the bottom there left, it's telling us that we've got firmware version 1.43. Excellent. So let's turn the robot on. The robot was off, so let's turn it on. And now you can see that we've got some data coming in. Now, I'm not going to show you how to use eBot app. That's covered in a separate video. So we're just going to disconnect now, but that's confirmed that it's all going. And then now we're going to hop out of that, and we are going to open up Make Block Scratch, and we're going to start a new program. And we're just going to hide the animation window, the stage layout, just so we can see a little bit more. So what we're going to do is test the inputs first, and then we're going to test the outputs. So you make sure that you've got the eBot Junior or eBot Pro, if you've got the Pro, or the eBot Junior extensions installed, and there are instructions on how to do that. Second thing is you just need to have the mbot selected. Yes, the mbot selected. And then we need to connect the serial port COM5. So the serial port is showing connected up there. So now we can go to robots, and then the buttons there are green. So I've just closed the Arduino blocks and the Junior blocks because I'm working with the Pro, eBot Pro, but if you're working with an eBot Junior, it's pretty much exactly the same, except you don't have a second ultrasonic sensor and you don't have a crane, but other than that, it's exactly the same between the eBot Juniors and the Pros. Okay, so let's test the inputs. So we want to go to data and blocks. We want to make a variable, and we could just call it sensor data. Now you could make one variable like I just did, and then alternately read the data into that, or you could make a variable for each one simultaneously. It doesn't really matter. So let's drag the set over there, and let's go to robots now. These are our eBot Pro blocks. So there's no pins there, of course, that's the point. So let's read the left-hand line sensor. And sometimes it's useful just to make it a little bit easier to see is let's just round that down and pop it in there to read the variable. And now let's just slow it down just a little bit. So let's put a half a second delay in there, just so the numbers don't tickle over too quickly, because sometimes it's a bit hard to see what's going on. And then now we'll need to put that in a loop. So that code is going in a forever loop. I want you to read the left-hand line sensor on eBot, and I want you to round it, and then I want you to put that value in the variable called sensor data. Now, to see that, I'm going to have to go and show my stage layout, because that's where the variable comes up. Now, to get it going, all I need to do is just click on it, and you can see there that the left-hand sensor value is 330. If I just get something black, pop it under there, so we've got something black, pop it under there, the value goes right down to 26. Okay, so that's confirmed. Let's turn that off, and now let's go and grab the right-hand sensor. We'll get that going again. So on the white surface it's about 350, that's fine. On the black it's about 10. Okay, so that's going fine too. The other way to make them bigger is the firmware puts the LEDs at 50% power, but let's say, for argument's sake, we wanted more light. We could make that 100% on the red, but just on the line sensor there. And let's turn those on. So now they're 100% red, and we'll just check that data. So now you can see that the line sensor has gone from about 350 to 500, because we've doubled the amount of light that's illuminating down onto the surface. About 600 is flooded, is maximum. Okay, and so let's get out of that. So we've done that, so let's continue on with what we're doing. So I'll put the ones that I've tested up the top there. Great, so let's go and get the ultrasonic sensor left-hand side. And you can't see it in frame there, but it's hitting something. It's only about 35-40 centimeters away from something. So I'll put something really close that you can see in frame there. You can see my hand now. So that's obviously working. So let's turn that off. So I'm clicking it on and off in between. Right-hand sensor, distance sensor. Turn it on to 35. Put something close to it. 5. That's working. Great. So put that up there. That's done. Now, potentiometer is another word for the Trimpot. If you're using a junior, then you will be called the joystick. X and Y you'll need to do. On the Pro, they've only got one Trimpot or potentiometer. So let's read that. So we're getting 100, so you can't see it, it's not in frame, but it's on the other side of the robot. So I'm just rotating that Trimpot knob, and it's going all the way down to 10, and then all the way back up to 100. So that's normal. It should go between 0 and 100. So that's perfectly normal there. 10 to 100 is fine. Click that off. So the potentiometer, or if you have the junior, as I said, you will have two. You will have one for the X-axis on the joystick and one for the Y-axis. Now let's go and check the button. If you have the junior, it's the button on the joystick. If you've got the Pro, it's a little red button next to the Trimpot. So let's start that, and that of course is digital, so it's either off or on, so I'm not touching it at the moment. Now I'm going to push it down. It's out of frame, you can't see it behind my hand there, but now it's 1, which means that I have pushed it down. I let go, it goes back to 0. Great, so they are all of my inputs, and they are now done. So I'm going to now hide the stage layout just to give me a little bit more room there. And we've already done some of the LEDs, so let's start our outputs with the LEDs. Now, I have already changed. I know that the line LEDs work. Let's go and do the front ones, and let's make them blue. Click on that, and you can see that they are blue. Well, hopefully you can. So they're blue. Now the line sensors underneath have still stayed red because we haven't given it any other instructions. Okay, now from there we've got the top. Yep, that's fine. Now we've got the top left. Let's make that green. that's working fine. We've got the right-hand side top. So, okay, yep, turn that around, that's clearly worked. And then the last one we've got at the back there. Now, if you have the Junior, obviously the LEDs are wrapped around the A-frame, but it's so that you won't have the top and the left and that type of thing. Now, what we can also do is let's just turn everything off. So I'm going to click on that, and now everything's gone off. So you can just type in the numbers that you want as well. So if I only want, say, LED, let's say LED 7 to be green at 100% luminosity, then that's LED 7. And so they're all individually addressable off the one pin, which is fantastic. And you can also give them any luminosity of red, green or blue. So you've got full luminosity control, full color control, and you've also got individual control over each individual LED off the one pin. So that's pretty fantastic. So that's LED number 7. It just starts from left-hand line, right-hand line, then left-hand front, right-hand front, and then it starts, that'd be 1, 2, 3, 4, and then 5 is just here as it comes out of the roll cage, and then goes in a clockwise direction, 6, 7, 8, etc., until it goes back over here. Okay, so you can just type in the individual number as well. So the LEDs, let's turn them all, let's make them all half purple, so let's say 40 and 60. And likewise, if I wanted 50 in there, I just type 50 and 50 and great. So they're all a bluey purple. Well, that's more bluey, isn't it? So no, that's no good. Okay, anyway, if you're not quite sure of the colours, which obviously I wasn't just then just go to the internet and look up an RGB calculator, and you will easily find for each colour, it'll give you the RGB, which is red, green, blue mix that you need. So this colour here is only 50% luminosity. So if I wanted to keep the same colour, but double the luminosity or the brightness, the amount of photons coming out, I would just go to 100, and now you can see that it's the same colour, but it's twice the brightness. All right, let's finish up there, but it's way too bright. Let's finish up there. Okay, the LEDs clearly work. So I am now going to pop that up there. So what I'm doing is systematically working through and popping the ones that I've checked up the top. Okay, let's go and check the claws. So the offsets and everything have all been set for the claws, and the motors in eBot app, I'd strongly recommend that you do it there. It is far easier and far better, and all the settings are saved in EEPROM on the robot. So this is the block that we're going to use, and we just click it, and the claw springs to life. So we're going to open it all the way. Clicking on it, yes, that's fine. Now we're going to close it all the way. Yep, fantastic. Now we're going to go make it go up all the way, which is 100, and then we're going to make it go down all the way, which is not being up at all. Now you'll notice the robot pops forward. That's a centre of gravity thing. It's not a design fault. We're actually well aware of that. However, the reason why we haven't, you can put a simple counterbalance on the back of the robot with a bolt and some washers, but we normally don't bother about it because you can't really drive the robot around with the claw facing forward because it obstructs your ultrasonic sensors, and usually you're never driving around without using the ultrasonic sensors. So because it blocks the ultrasonic sensors, you can't drive around with the claw down. And as you'll see, we actually have designed, that's part of the reason we have that lip at the front of the robot. So we've got that lip here, is that when the claws come down and obviously the centre of gravity changes, the robot falls down but hits that lip. So, and we sort of want it to tilt forward, because what it does, it allows us to pick things up lower than we otherwise would. Because if the robot doesn't tick, we get an extra inch, so we can pick things up lower by allowing the robot to tick forward. So rather than it being a design fault or something that we've forgotten about, or of course we're well aware of centre of gravity issues, but we have actually designed the robot to tilt forward and then sit on the bumper bar lip, which allows us to grab things lower, okay? And we've also considered that we just don't really drive robot around with the claw down, because it interferes with the sonar sensors. Great, so let's get back to business here. So let's put this claw back up all the way. Thank you very much. Now let's turn the claw off, and that completely kills the claw and stops it chewing up any current and making some little buzzy humming noises. So the claw is completely okay. So let's pop that over there. Now we're going to test the two motor blocks. Now I am going to put something underneath like that, so that the robot doesn't take off. So, all right, both wheels are going. I'll turn it around so you can see it. Oh, you won't be able to see both wheels at once at the moment, unless I turn it around that way, perhaps. If you can see it. Both motors are going forward. Okay, we'll turn it like that. All right, that's a good idea. So you should be able to see that now. What you can also do is... Okay, so let's go backwards. Click it. Yes, going backwards. Let's turn right. That's correct. So the left motor would go forward, the right motor would be still. And let's turn left. Correct, that's working fine. Now let's tell the robot to stop. So that would simply be 0. Right, so they're both stopped. You've got a slight amount of movement on that right-hand motor, but as I said, you can use the offsets, which are here, but I would strongly recommend that you don't. I'd strongly recommend that you use eBot app to set the offsets for the crane and the claws and the wheels, because you have a lot more finer control in eBot app, and then it throws those values to EEPROM, which is a separate part of the memory on the chip, to the programming menu. So it's on the robot all the time, and it remembers it every time you're using this, okay? So that's all great. So that block works perfectly. Now we have our differential drive block. So I'm just going to move over there. Our differential drive is the robot's tank drive, obviously. So that's this one. So let's go forward, both left and right motors. Fantastic. Let's go backwards for both of them. Yes. Let's turn one off. Yes. And let's turn the other one off. Yes. Perfect. No problems there at all. Excellent. Now, that concludes everything that we can test. We can't test if you have the display, the LED display on, I'm not talking about the LED strips, I'm talking about the dot matrix display screen. If you have that, we can't test that for software reasons in tethered mode. It will only work in compiled mode. Excellent. So what we could do now is we could just put all that together by making a quick little program to test these things as well. So, oh, that motor's creeping a little bit. So let's take this opportunity to set some of the wheel offsets. So that's going to be, no, let's not do that. Let's just kill the motor. So we've got wheels off. There we go. Excellent. So that's the other thing, is that you can actually just turn the wheels off altogether, and that's not a bad thing to do. All right, so let's make a little program that, let's pop this robot down. Let's make a little program that reads the, well, let's make a little program that drives towards the edge of the table. You can probably see there's an edge of the table there. I'll move the camera a bit. Okay, so there's an edge of the table there that drives forward on the edge of, and then it'll back up when it sees the edge of the table. So, okay. So what we need to do is, we've already got an idea of the light values, but what we want to do is go and read any light sensor. Let's do the left one, and we need to go back and see our stage layout. Now we're just going to read that, and we're going to go and set our LED to red 50%, which is a very good starting point. There we go. And that's just going to be the line sensor. So let's start that again. So now the line sensor is set at 50% red, and you can see on the sensor display variable there that it's 500 or so. So let's just, I'm just physically moving the robot forward until I get to the edge of the bench, and then the value goes down to about 150. Excellent. So 400 on the table, 150. So 150 to 400 is 250. So we want to go halfway between. So half of 250 is say 125. Add that to the 150, it'll be 175, 275. Well, you could take the arithmetic average. So 275 is halfway between our two readings. So what we want to do is make a simple decision where if it's bigger than 275, then it's more likely to be on the white reflective surface. But if it's less than 275, then it's more likely to be over the edge of the table, so it needs to back up. Okay, great. So let's go get a if then else statement. So that would be here, and we can just drag left-hand light sensor, and we need an operator, so we want to ask the question less than, pop that in there. So we're going to read the left-hand light sensor, put that in a forever loop, and if it's less than 275, then what we want to do is back up. So we just get our drive block, and we want to go backwards for 100, that's correct. And we probably want to do that for a certain amount of time just to get away from the edge, I would say. So let's do that for 2 seconds. Now, if it's not less than 275, then it's obviously on the white, so let's just drive forward. So let's get our drive block again, and let's drive forward, but let's go a little bit slower. Let's drive forward at 40. You don't need a timer there. Okay, so I'm going to put my hand over here and catch it after I start it. So let's see how we go. So that's working great, except now the robot kept going there. So when you're in tethered mode, why does the robot keep going? Well, it keeps going because the robot will keep doing whatever you tell it to do, whatever the last thing you told it to do. So if I'm just going to tell the wheels to be off now, so I'm just issued the wheels off command. So that's an example of what you could do there.